In this video, we're going to be looking at finding the area bounded by the curve and the x-axis. However, in previous examples, we've always had a sketch of the graph. In this video, we're going to look at the scenario where we don't have the sketch of the graph. Here are some notes. When we are finding areas under curves that have functions whose graphs are not easily sketched, the areas can be calculated provided the x-intercept can be determined. We are already familiar with this absolute value sign as we've been using it with any areas that are already below the x-axis. This method means that if we take the absolute value of everything, then we will always make sure we have a positive anywhere that there is a negative. Let's just check we can use the absolute value function. The absolute value of -5 is 5. The absolute value of 3 is 3. Let's look at the general case. As you can see, I do have a sketch here. We have to work through this in the case and that we don't have a sketch. What we're actually going to do is, as long as we know the bounds between we're finding the areas, so in this case, we're finding the area of this curve f of x between A and B, as long as we know where all the intercepts are in between those two A and B, so C here is the intercept, we can find the area by breaking it into two parts. We can find the absolute value of the area between A and C and the absolute value between C and B. If we were to write that down, we would write the area equals absolute value between A and C of the curve or the function f of x plus the absolute value of C to B. Now, as you can see in the sketch, in this particular instance, C and B is above the curve. However, without the sketch, we wouldn't know that. So to be on the safe side, we put the absolute value of each thing in between each x-intercept. So I'm finding the absolute value between C and B of f of x with x. Let's go through an example. Example 1, we're going to find the x-intercept of y equals sine 2x over the domain where x has got to be greater than or equal to 0 or less than or equal to pi. Then we're going to go on and calculate the area that is bounded between the curve and the x-axis at x equals 0 and x equals pi. So let's find those x-intercepts first. To find the x-intercept, remember, we always substitute y equals 0. So if I put y equals 0 into my function, I get 0 equals sine 2x. You need to say to yourself, that's a boundary angle. To make life easier, I'm going to substitute 2x for theta. This means I'm only solving sine theta equals 0. Remember, sine is to do with the y coordinate. So what we need to do is go around this unit circle and go, at what point of what angle is the y coordinate 0? This coordinate here, at this point, is 1, 0. This coordinate here, at pi, is -1, 0. We can see that at the angle 0 and at the angle pi, the y coordinate is 0. Therefore, our solutions for the x-axis are theta equals 0 and 2 and pi. However, we have to go between the domain of 0 and pi, so we need to go around the unit circle again. We go around the unit circle again, we then find out that we have 2 pi, where the y coordinate is 0, and 3 pi, and 4 pi. Remember, these are not our x-intercepts because we've done this substitution. We've said theta equals 2x. To find our x-intercepts, let's substitute all of these back into this. So the first solution equals 0. Therefore, x equals 0. The second solution, 2x equals 5. Therefore, x equals 5.2. The third solution, and right underneath, 2x equals 2 pi. So therefore, x equals 2 pi over 2, so therefore x equals pi. Next, we've got 2x equals 3 pi, so that gives us 3 pi upon 2. And finally, we have 2x equals full pi. So x equals full pi upon 2, meaning that x equals pi. So summarising, our x-intercepts are 0 upon 2 pi, 3 pi upon 2, and 2 pi between the domain of 0 and 2 pi. Let's go on to part B. We have to find the area now. In the question, it said find the area between 0 and pi. And we have to look at our x-intercepts and say, well, how many x-intercepts are there between 0 and pi? There's one here, pi upon 2. So I need to set up two intervals. Find the area between 0 and pi of sine 2x dx. We'll set up two intervals. Okay, so, and remember, because we haven't got a sketchy graph, we'll take the absolute value. So to begin with, we go between the first intercept, 0 and pi upon 2 of sine 2x dx, absolute value, and we're going to add to it from, so we're reading from left to right, we would go from pi upon 2 up to pi of the same function, and we would take the absolute value. Okay, now I need to now integrate. So I've got, obviously this is going to give me the same integral. So as I integrate, this becomes minus a half cos 2x, and I'm going to go between 0 and pi upon 2. And obviously I'm going to write that out exactly the same again. Only this time I'm going between these two and take the absolute value. Okay, now we've got to start substituting in, so I'm going to write really small. Remember, I'm taking the absolute value. So to begin with, I'm going to substitute in pi upon 2. So I've got minus a half cos 2 pi upon 2. Take away, now I'm substituting in 0, minus a half cos of 0. That's the first one. Plus, let's substitute now in pi into this. So minus a half cos of 2 pi minus, and now I'm going to substitute in pi upon 2. So I'm not sure I'm going to fit this all in. So I'll just move across. Cos 2 pi over 2, an absolute value. All right, let's calculate. Don't forget, we've got to work out here, the 2's will cancel out. So we're working out what is cos of pi. I'm just going to scroll back up to our unit circle and just have a look. These are also boundary angles. Remember that cos theta is to do with the x-coordinate. So let's find where we want cos of pi. So here's pi. What's the x-coordinate at pi? It's minus 1. So cos of pi is minus 1. We also need to find what cos of 0 is. So where is the x-coordinate 0? Cos of, let's write down what this coordinate here is. So this coordinate here is 0, 1. The x-coordinate is 0 here. So cos of 0 is 1. Hang on. Sorry, confusion there. It's here. Cos of 0. I'm looking not pi upon 2, my mistake. I'm looking at 0. So we're looking at the x-coordinate. So cos of 0 is 1 there. That's the one I was looking at. And then I want cos of 2 pi, which is the same. 2 pi is down here, so it's exactly the same. Cos of 2 pi is 1. So now scroll down, I can now substitute in those values. Working these out, I've got minus a half. So remember, cos of pi is minus 1. So I've got minus 1 times minus a half, which is a half. Minus, so cos of 0 is 1. 1 times minus a half is minus a half. So minus a half. Plus, now I'm on to this one. Cos of 2 pi is 1. 1 times minus a half is minus a half. Take away, and then just scrolling over, that's cos of pi again. Cos of pi is minus 1. Minus 1 times minus a half is a half. Now I can work that out. Half plus a half is 1. plus minus half is minus 1. Take the absolute value of 1 plus 1, so the area is 2 square units. Let's go on and look at a second example. This time we've got to differentiate a function and then integrate. Remember, if you see this in a question, you need to say to yourself, this is integration by recognition. Part C asks us to go on and find the area between the graph and the x-axis, between x equals 2 and x equals 3. So this is a general rule. We should be able to integrate through. We should be able to differentiate this just by using the quick version. However, if you forget, we can always use the long version of the chain rule. So I'm going to differentiate that using the long version. I'll just write the function we're dealing with the natural log of x squared minus 1. Using the chain rule, y equals the natural log of u, and we'll let u equal x squared minus 1. The y du equals 1 over u, and du dx equals 2x. Placing them together, so multiplying this by this, gives us dy dx. So dy dx equals 2x multiplied by 1 over u, and we'll substitute u back in, which is x squared over 1. Sorry, x squared minus 1, so we get 2x over x squared minus 1. That's part A. Okay, part B wants us to integrate. Now we look at the function that we're going to integrate and see if we can find a relationship. This is 2x over x squared minus 1, and this is x. So we obviously have an extra 2. First thing I'm going to do is set up the integral, where the integral of this is this, plus c. So let's write that down first. So the result of part A, the integral of 2x over x squared minus 1 with respect to x equals the natural log of x squared minus 1 plus c. Remember, we have to plus the c because this is an indefinite integral. Now, I need to remove that 2, so I'm going to take that 2 out as common factor and write the left-hand side and the right-hand side as follows. And then, of course, to make the equation correct, I'm going to divide both sides by 2, leaving me the integral of x squared minus 1 with respect to x equals 1/2 natural log of x squared minus 1. This is what we want. Part C asks us to find the integral between, the area between the graph and the x-axis at 2 and x equals 3. So the first thing we need to do is find the x-intercepts. So I'm going to write the function down that we're dealing with first. We're dealing with y equals x over x squared minus 1. So to find any x-intercept, we substitute y equals 0. So let's do that. 0 equals x over x squared minus 1. Now multiplying the denominator over here gives us 0, so therefore x equals 0 is an intercept. Now we need to integrate between x equals 2 and x equals 3. X equals 0 is outside of this region, so it's not going to affect our integral. So I've only got one integral. I'm just integrating this function between x equals 2 and 3, and there are no other intercepts in between. So setting up the integral is easy. Remember, we have to take the absolute value because we do not know if this is above or below the x-axis. So I'm setting up the integral, and I'm going to go ahead and integrate it straight away. Remember, we have just integrated this via recognition, so we know that the integral of this function is a half natural log of x squared minus 1. And of course, I'm going to substitute in the right order those numbers. So, substituting in the absolute value, I'm going to change to curved brackets now. Okay, so I'm substituting 3 in first. So 1/2 natural log of 3 squared minus 1. Take away, now I'm substituting 2 in. 1/2 the natural log of 2 squared minus 1. Absolute value. Okay, so 3 squared is 9. 9 minus 1 is 8. So I've got 1/2 natural log of 8 in this bracket. Subtract in this bracket 1/2 natural log of 2 squared is 4, minus 1 is 3. Okay, so if we're working out this as though we don't have a calculator, we can use our log laws. Remember, if you have the same base, which we do, it's the natural log for both of them, and there's a subtraction between them, we can divide these numbers. So this becomes the absolute value of 1/2 the natural log of 8/3. Now, without a calculator, that's as far as we can go. So we would leave our answer in exact form as so.